Today in lecture we were learning about conditional probability, and unfortunately we were cut short before we could get to this last example, well one of the last. I'll work on example 2 as a demonstration of how you should approach your homework problems. So example 2, in chapter 10, we see that jurors in an American court system, jurors make the right decision on guilt and innocence about 95% of the time. And 80% of all defendants are truly guilty. So now we're presented with a table where we're supposed to construct conditional probabilities based on 100 defendants sitting in front of us. So let's say that we had a total of 100 defendants. And just a little bit of background on the legal system. Anybody who's being charged with a crime, they are going to be considered a defendant. If they're really guilty, meaning they did it, someone who did it and is truly guilty should be convicted. So, just as a little background, the guilty should be convicted, where they're sent to jail, they're sentenced, whether it's a fine or time in prison. Meanwhile, the acquitted means that all charges are going to be dropped, you have been declared innocent, you did not do it. So innocent people should be acquitted, basically allowed to walk free. So in a perfect day, in a perfect world, everybody who actually commits a crime will be convicted. Everyone who did not commit a crime, but is being accused of a crime, is going to be acquitted. So I hope that's clear. So if we have 100 defendants sitting in front of us, 100 people who are being charged with a crime, first we need to figure out what percentage of those 100 are actually guilty. Who are the ones that actually did it? So we go back up to our base information, and we find that we have two statements. The first statement is talking about the juror's decision. The jurors make the right decision about 95% of the time, so convicting the guilty and acquitting the innocent. They do correctly 95% of the time. The second fact, 80% of all defendants are truly guilty, that's the first one we want to go to. That's the fact that separates the innocent from the guilty in terms of our totals column. So we're going to say, okay, of the 100, if 80% of the defendants are truly guilty, we're going to say that 0.8, 80 basically, 80% of the 100 are truly guilty. So 0.8 times 100. So out of the 100 defendants, 80% of them, or 80 of them, 80 individuals, actually did it. They are guilty. Which leaves, if we have 100 defendants sitting in front of us, 100 minus that 80, since these two have to total up to 100, the 100 minus the 80 leaves 20 individuals who are completely innocent and being falsely accused. So we've accomplished the goal with this this second fact, the 80% we've now put to good use. So now, once we've divided our defendants between being innocent and being guilty, the next thing we need to figure out is their likelihood of being convicted or acquitted. So, let's first look at the guilty. Of these 80 guilty defendants, the jury is now going to make the correct decision of convicting them 95% of the time. So 95% of the time, the jurors are going to do the correct thing and convict the guilty individual. So if we have 80 guilty individuals and 95% of the time they are going to be convicted, we can say that 0.95 of the 80 are going to be convicted. And that's going to give us 76. So we have 76 guilty people who were sent behind bars. Now, what about the guilty people that were not sent behind bars? Of the 80, 76 were sent away, which means that there were 4 guilty people who were allowed to walk free, where the jury has made the incorrect decision and has falsely acquitted a guilty person. So we can apply the same technique with the innocent people, only now, innocent people, the correct decision that the jury should make should be to acquit them. So 95% of the innocent people will be acquitted. So we have 20 defendants who are innocent. 95% of them will be acquitted. So we're going to say 95% of the 20 are going to rightfully be acquitted, where they're able to go home that night, no questions asked. So that leaves how many innocent people behind bars? Well, we have 20 defendants who are innocent, 19 of them have been acquitted, so that leaves one left over, one innocent person who has been falsely convicted and now is spending time for a crime they did not commit. Now the last thing is just the totals column. So we're going to add up the acquitted to see that 23 defendants total were acquitted and that 77 total defendants were convicted. So now we've created this table, so we're able to come up with, this is going to be our baseline to jump off of for creating these conditional probabilities. Basically, what's the probability of a convicted person being innocent, or the probability of an acquitted person being guilty, or the probability of an innocent person being acquitted. You can make so many problems based off of one table. So we're going to jump into that next. So the first conditional probability we're going to look at is asking for the chance of a convicted defendant being truly innocent. So they're asking, what's the chance that if a person was sent away to jail, that they really didn't do it? So we're going to look at this basically as fractions on our table. So what we're looking for is first, under the condition that someone was convicted. So we're first going to look at, out of all of the convicted people, so I'm going to go to my table, find the convicted, and say, out of the total convicted, that's 77 people. So I'm looking at all of the convicted individuals. So under the probability, under the conditional probability that a defendant was convicted, so out of these 77, how many were truly innocent? So out of these 77, I go up to look in the innocence row. So out of these 77, one of them that was convicted was innocent. So there was one innocent individual out of the 77 convicted. So there's basically a 1 in 77 chance of a person who has been sent to jail really being innocent, they didn't do it, they're being falsely accused and falsely charged with a crime. Now part 2 is asking us, under the conditional probability that a defendant has been acquitted, what is the chance that they were truly guilty? So of the people that we allowed to walk out of the courtroom, how many of them were guilty? So we're first going to look under that only at the acquitted individuals. So out of the acquitted, the total acquitted, we're going to first look at the total acquitted. So there were 23 defendants who walked out to go home that night, that they were completely acquitted of all charges. So out of those 23, how many of them really did it? So then we go up to these 4 that were truly guilty. So we would say out of the 23 acquitted, there were 4 truly guilty defendants. So 4 out of 23, which is much higher than our first one. Sounds like there are a lot more people. You have a much greater probability of being acquitted of a crime that you did do, rather than being convicted of a crime that you did not do. So the take-home point that I really want to stress is the hardest part about doing these problems is figuring out which facts to apply where. We were given 2 facts. First, 80% of defendants were truly guilty. That was the fact that you applied to the total column, that applies to the total 100 defendants. Then the next problem, or the next fact that you apply, is kind of a sub-fact, where it's talking about, once we've divided into guilty and innocent, what percentage of them are, correctly decided upon by the jury, and that was that 95% fact. So it's a matter of figuring out which fact to apply where, one to the outside and one to the inside. So you just have to use logic and intuition, and then just be very, very careful with reading your numbers for doing these conditional probability problems. Good luck.